Hello, and welcome to a FortiWeb video on API protection. FortiWeb gives you end-to-end API protection solution. It handles access control through API gateway and mobile API security, making sure only the right users get through. With OpenAPI Validation, it checks that incoming requests match your API specs. It also supports JSON, XML, and GraphQL, so you're covered no matter what format you're using. And with machine learning built in, it can spot abnormal or malicious behavior in real time, keeping your API secure and running smoothly. All right, let's start by checking out the features that handle API access control. FortiWeb's API Gateway provides robust API management by enforcing access control through API key verification, ensuring only authorized users from defined user groups can access the API. Configuring an API gateway requires three core components. First, user management involves creating API users, assigning unique API keys, and enforcing role-based permissions to restrict access to permitted resources. Second, security enforcement applies API key verification to authenticate requests from specific user groups, while rate-limiting rules prevent abuse or system overload by capping request volumes per client. Finally, URL-specific configurations allow exemptions. Certain sub-URLs can inherit distinct rate limits or bypass default rules entirely, ensuring granular control over traffic policies. This structured approach harmonizes security, scalability, and precision in managing API interactions. Let's take a look at examples of the API Gateway feature in action. In this example, your API is set up to allow access only to authorized users with valid API keys. Each user belongs to a specific group, each with its own rate limits and access permissions. User group A is allowed to access /API/v1/data with a rate limit of 100 requests per minute, while user group B can access /API/v1/reports, but is limited to 50 requests per minute. If a client sends a request without an API key, or an invalid or revoked API key, FortiWeb validates the API key against a list of authorized keys and blocks or allows the request accordingly. In our second example, an attacker sends a request with a valid API key but attempts to access an endpoint that their user group is not authorized to use. For example, a user from user group B tries to access /API/v1/data. FortiWeb checks the user group associated with the API key and verifies if the group has permission to access the requested endpoint. If not, FortiWeb blocks the request and logs the violation. In our third example, an attacker or a misconfigured client sends a large number of requests in a short period, exceeding the rate limit for their user group. FortiWeb enforces rate limits based on the user group. If the rate limit is exceeded, FortiWeb blocks further requests from that user and logs the violation. Lastly, an attacker attempts to access a restricted sub-URL that is not allowed for any user group. For example, try to access /API/v1/admin. FortiWeb checks the sub-URL against the access control rules. If the sub-URL is restricted, FortiWeb blocks the request and logs the violation. By leveraging these features, FortiWeb ensures that only authorized and well-behaved clients can access your API, providing secure and controlled API access. FortiWeb's mobile API protection feature validates JSON Web Tokens presented by mobile applications. It goes beyond validating the user. It verifies the integrity and legitimacy of the mobile app itself. It checks if a request contains a JSON Web Token, whether the token is valid, and flags the request accordingly, whether there be no token, valid token, or invalid token. Based on these flags, actions are enforced, ensuring only authorized mobile traffic is allowed and enhancing security for mobile API interactions. Let's take a look at some examples of the mobile API protection feature in action. Your mobile application communicates with the backend API using JSON Web Tokens for authentication. A typical request might look like the figure on the left. In this case, an attacker or a misconfigured client sends a request without a JSON Web Token, or a request with an expired JWT. FortiWeb checks flags the request as no token or invalid token, then blocks it, ensuring that only authenticated requests are processed. If the JWT token is tampered with and results in an invalid signature, or the JWT token is with invalid claims or other situations where the JWT token is invalid, FortiWeb can detect it, flag the request as invalid token, and block it. Once FortiWeb confirms the API request is coming from a legitimate source, it digs deeper, checking if the API format like JSON, XML, or GraphQL meets the size limits, schema, or any other rules you've set. FortiWeb's JSON Protection allows you to configure detailed validation rules for JSON data, helping to secure your application against malicious input. You can control the size of the JSON document, key and value sizes, as well as the number of keys, values, and array elements, and the depth of nested objects. In addition, FortiWeb supports JSON schema validation, which ensure that incoming requests conform to predefined structures, enhancing the security and reliability of your API. FortiWeb's signature scan is also available in JSON Protection, providing an additional layer of security by detecting and blocking known attack patterns and vulnerabilities in JSON payloads. For example, let's say you have a RESTful API that accepts JSON payloads for user registration. The expected JSON structure might look like the example on the left. An attacker, however, sends a payload that exceeds the allowed size limit for certain fields, such as an excessively long string in the username field, or an excessive number of keys, potentially attempting to overwhelm the server. If the JSON payload exceeds the specified number of keys, FortiWeb will deem it a violation. In another example, let's say you have uploaded a JSON schema and it specifies the JSON structure like the example on the left. An attacker sends a JSON request where the email field is missing and an unexpected age field is included. When FortiWeb detects this schema violation, it can block the request and log the attack. FortiWeb's XML Protection feature secures web applications by enforcing strict security controls. It limits XML content, blocking malicious entities like XML external entities, XXC, and schema location injections. It also validates messages against schemas such as XSD, WSDL, and DD. To ensure message integrity, FortiWeb provides WS security rules for encrypting, decrypting, and digitally signing parts of SOAP messages. Additionally, it detects XML signature wrapping (XSW) attacks by verifying signed nodes using XPath and certificates. You can configure exemptions for trusted URLs while maintaining protection for the rest of the application. FortiWeb's signature scan extends to XML protection, adding another layer of security by detecting and blocking known attack patterns and vulnerabilities in XML payloads. Let's go over some examples of XML protection in action. Your API expects an XML payload to process an order with a specific structure. While real-world implementations may vary, we are using the structure to illustrate different attack scenarios. An attacker sends a malicious XML payload that includes an external entity reference, attempting to exploit an XXE vulnerability to read sensitive files on the server. FortiWeb detects the entity declaration and blocks the request, preventing the server from processing the malicious payload. In this case, an attacker sends an XML payload containing a malicious schema location attribute, attempting to redirect schema validation to an untrusted source. FortiWeb validates the schema location attribute and blocks requests that reference untrusted or malicious schema locations. Finally, in this case, an attacker sends a malformed XML payload, attempting to crash the server or exploit parsing vulnerabilities. FortiWeb validates the structure of XML payloads and blocks malformed requests that do not conform to proper XML syntax. FortiWeb's GraphQL Protection safeguards GraphQL APIs by limiting query size, complexity, and resource consumption to defend against malicious queries, signature attacks, and performance bottlenecks. Key features include restrictions on payload size, value length, object depth, and a number of fields or queries in alias or array batches. It also offers controls over introspection queries and fragments to minimize schema exposure. FortiWeb's signature scan is also available in GraphQL Protection, providing an additional layer of security by detecting and blocking known attack patterns and vulnerabilities in GraphQL payloads. Let's go over some examples of GraphQL protection in action. Your API expects a GraphQL query to retrieve user information with a specific structure. While real-world implementations may vary, we're using the structure to illustrate different attack scenarios. In our first example, an attacker sends a batch query with an excessive number of fields, attempting to overload the server. This exceeds the expected query size, and FortiWeb blocks the request. In a different case, an attacker sends an introspection query to extract sensitive information about the GraphQL schema, potentially identifying vulnerabilities. FortiWeb provides controls over introspection queries, allowing you to restrict or block them entirely. This minimizes schema exposure and reduces the risk of attackers exploiting schema information. In our final example, an attacker uses fragments to create a highly complex or malicious query, attempting to bypass query complexity limits. FortiWeb enforces strict controls on fragment usage, including restrictions on recursion. If a query exceeds these limits, FortiWeb blocks the request. By leveraging these features, FortiWeb ensures that only well-formed, valid, and secure GraphQL queries are processed by your API, protecting your application from a wide range of GraphQL-based attacks. FortiWeb can also zoom in on the API schema itself, just like with the OpenAPI Validation feature. FortiWeb's OpenAPI Validation feature helps ensure that only properly structured API requests are processed. You can upload an OpenAPI description file that defines your API structure, endpoints, and data types. Once uploaded, FortiWeb parses the file and uses it as a baseline to validate incoming requests. It blocks any requests that do not conform to the API specifications, such as those with unexpected endpoints, invalid parameters, or mismatched data types. Requests that match the defined API structure are allowed. Let's go over some examples of OpenAPI validation in action. Your API is defined by the following OpenAPI specification, also known as a Swagger file. An attacker sends a request to an endpoint that is not defined in the OpenAPI specification, such as /admin. FortiWeb validates the request against the OpenAPI specification and blocks requests to undefined endpoints. It ensures that only the specified endpoints are allowed. In our second case, an attacker sends a request to the /user's endpoint with an invalid parameter type for user ID, such as entering a string instead of an integer. In this case, an attacker sends a request to the /user's /user ID endpoint with a path parameter that does not match the expected data type, say, a string instead of an integer. FortiWeb validates the path parameter against the OpenAPI specification. Since user ID is defined as an integer, FortiWeb blocks the request with a string value. Lastly, an attacker sends a request using an HTTP method that is not allowed for the /user's endpoint, for example, post instead of get. FortiWeb validates the HTTP method against the OpenAPI specification. Since only GET is allowed for the /user's endpoint, FortiWeb blocks the post request. By leveraging these features, FortiWeb ensures that only well-formed, valid, and secure requests are processed by your API, protecting your application from a wide range of OpenAPI-based attacks. FortiWeb also brings it all together with an API protection feature that covers every angle. The machine learning-based API protection learns the REST API data structure from user traffic samples and then build mathematical models to screen out malicious API requests and prevent sensitive data leakage in API responses. It implements 3 layers of protection: schema protection, threat protection, and sensitive data leakage prevention. It also supports continuous learning that ensures the model stays up to date with evolving application structures. The schema protection model consists of 2 main functions: API discovery and API protection. It analyzes the method, URL, and endpoint data of the API request samples to generate an API data structure file for your application. If the incoming API request violates the data structure, it will be detected as an attack. The threat protection model learns parameter value patterns in API request bodies and then identify API requests with abnormal parameter values. Sensitive data leakage prevention integrates with FortiGuard's extensive, customizable database of over 500 predefined data patterns and policies. The ML-based API protection adds another layer of identification and visibility into potential exposure of sensitive information in API responses. Continuous learning of the ML-based API protection enables the model to automatically adapt to changes in the API schema. This includes handling scenarios such as adding entirely new endpoints or services to the application, updating the structure, data types, or values of existing parameters in API requests or responses, recognizing newly added optional fields or required parameters in API calls, adjusting to modifications in API endpoint paths, and adapting to altered JSON data formats used in API exchanges. All of these factors contribute to building a new continuous learning model. These capabilities ensure that the model remains flexible and aligned with dynamic API environments. Let's take a look at the ML-based API protection feature through examples. Schema violation is pretty common in API protection, especially when a strict schema is in place. Assume FortiWeb has learned the API schema of the application as shown. It defines the type, properties, and the required fields. Here comes a request whose ID value 123ABC is a string violating the schema's type definition. FortiWeb detects these type violations to ensure API data conforms to the correct structure. Another violation example is that the incoming request is missing the name property, violating the schema, which states that both ID and name are mandatory. Here is an example of minimum or maximum limits defined in the schema. A request with the age value 16 violates the minimum constraint, while another request with the age value 65 exceeds the maximum constraint. FortiWeb detects these violations to ensure API data stays within the defined limits. Let's look at some examples of the abnormal parameters found in the API request. Anomalies like code injection, command injection, SQL injection, XSS, and other threats can be effectively filtered out by FortiWeb. In this example, FortiWeb learns the pattern of parameter values. Through observation of normal traffic, FortiWeb learns that the username is alphanumeric between 5 to 15 characters. The action is one of these allowed values: login, logout, or update. The timestamp is an ISO 8601 format. When a request like this comes in, FortiWeb will know it's an anomaly because the username contains an unusual pattern with embedded script, suggesting a possible XSS attack. The action includes an unrecognized value, pointing to a potential exploit, and the timestamp is malformed, hinting at a possible SQL injection. In conclusion, with extensive API security capabilities, FortiWeb provides comprehensive protection aligned with the OWASP API Security Top 10, offering advanced defenses to secure modern application environments. Thank you for watching.